Welcome to Study Loop.
Okay. I wrote down m equals 2 and the theta that we're given and the v of light from a distant galaxy. We know for a diffraction grating that m lambda equals d sine theta. So, what I am thinking is that for helium, in this case, this is happening on Earth with the speed of light on Earth, and so speed of light equals wavelength times frequency for helium. However, for this far away galaxy, it's traveling away from Earth. Just want to make sure that that's correct. Away from Earth, so it's going to appear to have lower speed, and that's going to be the wavelength distant times frequency. So if I rearrange, I get c over wavelength h helium equals the frequency, which equals c minus v over wavelength from distant. And so, rearranging that, the distant wavelength is c minus v over c times the wavelength for helium. All right. Since m lambda h equals d sine theta h, and m lambda d equals d sine theta d, then I can rearrange both of them for m over d. So m over d would be the sine of theta h over lambda h, which is the same as the sine of theta d over lambda d. Now, if I rearrange this and solve for theta d, then I get theta d is the inverse sine of lambda d over lambda h sine theta h. But up here, I know that lambda d over lambda h, just rearranging a bit, is c minus v over c. So now that's going to be the inverse sine of c minus v over c sine of theta h. C is 3 times 10 to the 8th power meters per second. Theta h is up here, and so is v, and so is m. Oh, we don't even need m. We can put those into the equations, and I get theta d equals 17.2 degrees. Now, what's written in numerade is 20.7, I mean, really 20.6 degrees. And how you get that answer is that you change this C minus V to C plus V. C plus V. And so we'd have plus here. That will give you the 20.6. But I believe this one's correct because the light is moving away from Earth. If we're on Earth and the light is moving away from Earth, then the relative velocity would be slightly less. And that's why I'm using minus, slightly less. If it was coming toward Earth, then the relative velocity would be slightly higher. So I believe this is correct, but I could be mistaken. And it could possibly be this.